Yo, what's up, everybody? Welcome back. Today we're working on our collaborative Rube Goldberg machine, and today's topic is building up the collaboration system, i.e., WASM-based chambers. So, context for the project is when I was a kid, I used to go to Science World. This isn't a video of me, but it's somebody's video from the internet or from the same place. Science World is this place in Vancouver. There's this ball machine outside, and like the best part of going to Science World was just like watching these balls roll around this machine. It's just kind of fun to look at stuff. And so I kind of thought it'd be fun to make something that's like this, that's virtual, but like collaborative, right? So it'd be cool if we could like build up this like complex machine that's made up of like several individual components where each component is submitted by some user. And the fun part there is that it lets us like explore a few concepts. We get to play with physics systems, and like since balls are a lot like particles, like by extension a little bit we'll get a feel for like particle systems. We get to play with like running wasm on the server as a way to like sandbox user code but still run it, and we get to play with like, I don't know, there was something else in there, I can't really remember what. Anyway, where we're at right now is we have this pretty rudimentary simulation where we have some form of physics that's going. You can see that, well, you'll see in a second, the balls do in fact bounce, and when they hit each other, they do move around. There's a little bit of bugs in our physics, like for example there, it just pushed a ball through the wall when it wasn't supposed to, but we'll fix that eventually. And what's happening here is we have platforms that are moving back and forth that are based off of our current plugin system. So right now, we just kind of hard code in our server that we are loading this chamber. And this chamber also is compiled as a WebAssembly module that is loaded in the browser. And we basically share state between the two. So the server does like this physics simulation. We want this physics simulation running long term on a server because it's just kind of more fun to see like long term effects of something. We don't want it to be completely client side. So all the physics and like platform movement kind of has to be controlled on that side. And then each plugin serializes its current state and sends that up to the browser. And then the browser goes, hey, you told me to give you this. And he hands him off a list of platform locations. And the WebAssembly module renders this into a canvas that's then displayed on the client. Yesterday, we started looking at wasm support. So we pulled in wasm time, which is this like WebAssembly runtime that you can run in C. It's written in Rust, but we have access to like a C API that we load from Zig. And we got to the point where, let's see, we'll see if we have a really, really shitty demo. Zig out bin wasm chamber. So this isn't too interesting, but it prints out onto our terminal like the internal state of this chamber, which means that we've successfully loaded our wasm module and we've correctly hooked up like memory input and output, right? So if we want to like write a string somewhere, we have to like in wasm say, here, we'll draw it out. We have to say wasm. He has like a linear chunk of memory inside him, kind of. The like wasm execution environment, he kind of like sets this thing up in a way where like our program can access it. So the wasm module, like he's taken a string of stuff that he's serialized, he's like written it in here, state, and we've like fed in like a function callback that can be called from wasm to like print this to the screen, right? So it's sandboxed, we give it one function that it can call right now. What we want to do is we want to continue working along this way. So the thing, like right now, the plugin still isn't doing anything. We need to like run physics. And what that requires is it requires some form of like, we're going to have like a bunch of balls, right? Like we have in our example here, there's like 5 balls on the screen, right? Our server is kind of like somewhat in control of these, but the chamber is also somewhat in control of these. The server is going to apply like gravity, for example, every frame. It's going to like move them every frame according to their current velocity. But the chamber has the ability to maybe adjust these things in some way. The API here isn't like fully fleshed out yet. But the thought is that like say you had like a chamber and you wanted to do something a little wacky, like maybe you have like a planet in the center and you want like balls to kind of like come in and with some velocity like orbit this planet and then shoot themselves back out. Or maybe you want something like you have like a portal here and a portal here, and if a ball goes into the portal, it gets like launched out this one, right? Stuff like that, you need like kind of fine-grained control over the physics engine. So these wasm modules, they get passed in these balls, and they can do physics on them if they want, according to like whatever is in their scene. And we have to figure out how to actually do that. And the complication here comes from the fact that even though these two things here and here are like in the same memory space, you can't really use it like you would normally use a library, because the WASM stuff is like in a 32-bit virtual machine with like certain expected semantics, right? Like the WASM assembly instruction set, I think, doesn't support booleans. I'll have to double check this. I think like its booleans are represented as I32s, right? So you could imagine that if your booleans are represented as I32s, maybe your structures also store booleans as I32s. I'm not sure that that's the case here, but like you can't just like take struct ball and use it in both places. So I think that the first thing that we're gonna have to look at is like, how do we integrate these two things together? Once we have our chamber like fully integrated, then I think it makes sense to try to make a second chamber in C, because right now we're writing in Zig. I think that a nice part of using WASM as our scripting engine versus like just like Lua or something is, one, like performance, but two, that like people have the freedom to use it in whatever language they want. But if we want some sort of like consistent physics feeling, we need to make sure that people who are writing programs or chambers in different languages have access to the same physics system, right? They can choose, if they are in like this case where they want to do like orbits or like portals and stuff, they can choose to bypass the physics system. But we should say that like the assumption is that you will use the physics system if you can, and for us to do that, we need to provide a physics system that's like usable from multiple languages. So we have to make some library that we can link into WASM modules. We have to export it in a way that is like C ABI compatible, and then we can try writing a chamber in C to really just like flush that out. And then once we have a second chamber, we can make sure that we can like load multiple chambers. That's the plan for today. We'll see how far we get. I imagine that we kind of sorted out most of the WASM bullshit yesterday, so I think that we'll be pretty okay to just kind of steamroll through this, but we'll see how hard it gets. I missed a prime. Thank you for the prime on Nightly. Appreciate it. And I missed a raid from Mackie. Thanks for the raid. Hope you guys had a good stream over there. And oopsies, I don't know why I wrote 2:06 here. I wrote the time on my taskbar, not the time into the recording, which is what I usually do here. Okay, replace chamber with WASM. So what we have right now is we've been writing this like WASM chamber abstraction, and he loads like a bunch of like WASM time library stuff. So there's like an engine who's responsible for like compiling WebAssembly modules. There's like a store that's responsible for like internal state of the modules. There's like a context which has something to do with the store. I don't really know what. An instance which has something to do with the context. And I think an instance is like if you have like chamber.wasm, I think that this gets like compiled into like code, right? Code. Hand wavy. But this code can be like instantiated multiple times in the same way that you could have like a class where you have like class dog, and you can have like dog A, which is a dog, and dog is dog B, right? These are like, they use the same code, but they're different. They have like different chunks of memory and stuff associated with them. So I'm pretty sure that's the difference between like an instance here, is that an instance is like an instantiation of your class, where your class is your WASM module. We pull out like a reference to its internal memory for this instance. We don't really have to do this, but we do it this way because it allows us to like interact with memory easily. And then we have like a list of function pointers. They're like not really pointers, they're like WASM function pointers, but they're close enough. And then we just kind of wrap some functions. So when we load the module, we go like, hey, do you have like an initialization function? I sure hope you do, because I'm expecting to call it. And do you have like a log state function? I want that as well. And then we like call these things through some like WASM APIs where we like feed in our arguments as like I32s in WASM format, whatever, and then we call a function. So that also is like pretty straightforward, all pretty straightforward. So I think now what we have to do is we have to start like turning our chamber functions that we have right now, like this, specifically this like physics step function. This right now was being compiled directly as Zig and linked directly into our main executable. We have to turn this into something that's like exported. And I think that's mostly it. I think everything else is like not really used here. So we can probably get away with just working on this. So I think the first thing to do is probably make sure that this ball struct, we can't just feed the ball struct into WebAssembly already, like I was saying earlier. But like we could, if the alignments of all of the fields happen to line up, which I think they should, right? This guy has like a pos2, which is just 2 floats. He has a vec2, which is also just 2 floats. Then he has a radius, which is just a float. So like in any sane system, I shouldn't say any sane system, but for like x86, you would assume that this struct has 4-byte alignment and that all of the fields are 4 bytes apart. And I would assume in WebAssembly it is the same. And so I think that what I'm going to do first is maybe we will just say, we'll add a function that's like assert ball layout, right? And then we can just do something like, we can look at a ball and we can just say, stood, maybe, how do I want to do this? Yeah, maybe we'll stood assert. I think that's probably fine. We'll see what happens in assertions in wasm land. I don't really know how that's going to work out. But I think we can just do like offset of. Can you do like offset of subfields? I don't think you can do like offset of ball pause, which will tell you where this thing is. And we can just like assert that this is 0. And we can do assert that the radius offset is 4, 8. And the velocity offset is 12. And then maybe we can debug assert that the offset of pause x is equal to 0. It would be nice to be able to get like the pointer positions of every single field relative to ball. I wonder if you can do that. I think offset of only works with external packed structs. Interesting, good to know. Probably, I will want this to be an external struct anyways, though. This will eventually get moved into like a C header, I bet. That's what I'm assuming right now. But we'll see, we'll see. Can we like also check like the alignment? Align of? Okay, so we can assert that the align of ball is 4. That's kind of what I expect right now. I could be wrong. We'll see. Yep, and then I really want to be able to get like the field offset. So I know that like, because I'm not really positive, like even if the offset of pause x in pause 2 is 0, I don't know if we're guaranteed that within this struct it's the same, right? Because like maybe the struct is going to change alignment of fields in some way. So can we look up like zig get offset of field? Offset of, but offset of like sub field? Of struct member. We could do something like, instead we could do like const ball is equal to ball. Oopsies, ball is undefined. And we could do like ball x ball pause minus ball pause x and make sure that this is 0. That seems reasonable. I don't know what this is going to do, to be honest. But let's see. Let's see if this compiles. And then we can do the same for y is 4. And then we can do the same for velocity as well. Yeah. Yeah. Sure. Maybe. And then we can just go into like wasm chamber main and just like assert this. So we'll say physics assert ball layout. And I guess we have to const physics is equal to import physics zig. Okay, so zig build and zig out in wasm chamber. Let's just see what fucking happens. It's not marked public, so fine. If you're gonna be like that, zig, I'll do what you ask. Type of undefined does not support field access, so here I need to write that ball is a ball, to be honest. Incompatible types. Can I like cast this to like both of these to U64s or something? Maybe I'll cast them to U sizes. Int from pointer. Oh, good eye, good eye, good eye, good eye. I think I've made this mistake before. So this is int from pointer. There we go. Okay, let's try this first, and then we'll move on and see if the rest is okay. Okay, so he's chilling. And let's just double check here that like if we do something stupid, like check that it's 1, this should crash. Nice. Okay. So now we can just do the same for pause y. We can bring back this radius offset assertion, velocity, and then we'll just change these guys to velocity. Now you don't need usize. Oh, really? Int from pointer will always return a usize or something? Oh, it will. Sick. Thank you. Because I fucking hate... This is like the one... I think my one biggest gripe about Zig is these as casts. Like, I like intentionally write code to avoid them a lot of the time because it like pisses me off so much. And I guess probably this has to be 4. And this is the wrong way. Should be pause y minus the pause. Yeah, because I'm going to end overflow here. It's this way. This way. Okay. So this should fail because I wrote 0 here instead of 4, which I expect. So let's just double check that we see the failure case so that we know that we're asserting something reasonable. Good. This, we write 4 now. Okay, we're chilling. And then we can do the same thing here, but this we are going to copy these assertions here and change every instance of dot pause to dot velocity. There we go. Okay, struct layout is what we expect on our machine right now, and now we can just call this same function from within wasm, and let's just do something like if stood built-in target is wasm, stood debug assert false. I just want to see what happens in this case. Built-in equals import built-in. Okay, I think that's fine. That compiles. And now we just need to call this function from our wasm thing. So we'll look up chamber zig, and in initialization, which I believe we call, we should just be able to say physics assert ball layout. So when we call this now, I'm hoping to see something happen. Okay, we get an error from our wasm module, which is good. And it's not like crashing, it's just returning an error. So this is probably triggering like a trap case or something. I wonder what this does, to be honest. I actually have no idea what an assertion will do in wasm. It's going to call unreachable, so Zig must be injecting something. I wonder if we can like look. Wasm to what? Zig out bin chamber wasm. Fuck. Okay, so he does have this. Oh, interesting. He's got some strings in here, which are kind of fun. I wonder if we can write like panic hello world. Hello, panic world. And then when we build this thing, we should see that string somewhere. So in here we should see panic. How do I see that? Oh boy. Maybe this is more complicated than I thought. Built-in default panic. Like, is this defined somewhere? Default panic. Here we go. So he just calls unreachable. Oh, interesting. So there is a unreachable in wasm land. What? wasm what unreachable. What does it mean? What does it mean? It's an unconditional trap. In the case where it is reach and execute the instruction traps. Ah, okay. So I guess probably if we go into our chamber.zig, we will probably be able to, wasm chamber zig. When we call the init function, we should here see a trap. So let's std debug print, and can we print like any, we'll print error and trap. And let's new line that bad boy as well, actually. And we'll probably see that the trap, yeah, so we have no error, but we do have a trap. Interesting. So there's probably a way to like extract some interesting information out of a trap as well, to be honest. We can look at maybe wasm time trap. And let's just bump, 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 bump. So what does it have in it? So this is the wasm time trap from some random fucking website, but we'll assume that it's right. I wonder if we can like get like a error string from it. Wasm CAPI. Wasm time CAPI. Can we look up like, is this a wasm trap or a wasm time trap? Wasm trap. So this is going to be declared here probably. Okay. And it's just an opaque struct. So maybe maybe in wasm time they have functions that let us work with the trap in some way. Wasm time trap code enum. Trap code. So we can extract the trap code from this trap. Interesting. Which is probably what we want. We probably want to extract the code. Is there like a string that comes with it, or? So I'm assuming that we're looking for this. So we should be able to do something like see wasm time trap code from the trap. So we'll say if trap is not equal to null, we check the code. So we say wasm time trap code, and we have some out parameter code, and code will probably be a reference here, and we'll say code is a c int. I already forgot. Wasm time trap code. It is a wasm time trap code t. Okay, and then here we should just be able to say if code is equal to c wasm wasm time trap code unreachable code reached std debug print hit unreachable. So if we understand everything correctly, we should see a print of hit unreachable, but instead we ignored this thing, so we're just gonna hit this real quick. Good. Okay, that's pretty cool. Pretty cool. So that's kind of cool too, because it means that we can rely on assertions in our WebAssembly, and it's just like fine. Okay, let's leave this for a second and go back to our physics assertions here, and we'll just take this out, and we're gonna hope that all of this stuff just lines up. So no error there, which is very good. That's very good. Which means that the struct layouts are in fact the same. Hell yeah. Hell yeah. We should add one more assertion here. That the size of this thing is what we expect, because like maybe in the future we'll add a field to this thing and we'll forget that we added that, like it changed. So maybe we can do size of ball is equal to 1, 2, 3, 4, 5 times 4 is 20. Nice. My friend works somewhere where they have this like hard rule of no no magic numbers, which is like usually a reasonable like policy to have. But when I look at this and I'm like, these are magic numbers, but it would be so fucking stupid to me to write for me to write size of ball equals 20 and then write size of ball here. And then like they also get mad if your constants aren't defined in global space. So if you like you have to put this over here, which is just like so fucking stupid. Like anyways, uh yeah, define 4 4. Define 4 4 is what somebody wrote in chat. And you're kind of you're joking, but he has sent me screenshots of code that look like this, which is very funny to me. Because yeah, do they just have the great numbers.h file with 30,000 lines? Oh, dude, I had when I worked on camera firmware, we had some code that controlled some like stepper motors on this like really shitty board. Like it was absolute garbage. Like we stack overflowed and stuff all the time because we couldn't afford to spend like 3 extra cents for a little bit more memory. But the code for that thing had one file called functions.c, and I just thought that was the funniest fucking thing in the world. Like, you're like, well, it's where we put the functions. Like, what else are we gonna call it? And, every person who went through that code base was like, this is really funny. And like nobody ever like it's never worth changing. So it's just like that forever. We will always that company will just always have a file functions.c where you put the functions. uh okay. So I think that with the current struct layout, I think that if we go into our chamber zig and we try to write this as a exported function, I think it won't work. Because I think it'll say that like one, we can't have a field like this, where the ball is a slice directly. So we can probably do this though. This is probably okay. Except this probably isn't what we want because like copying the memory will become a little confusing. We probably want this. We probably want a C pointer to some balls as well as the number of balls as a U size. Yeah, I think that makes sense. And then this would be an exported function. I think it's pub export function, not pub function export. In fact, I don't have to think that. It says it right here. This probably won't compile anymore because numBalls is not used. So how do I do this? It's like for balls 0 to numBalls. And I think this is probably the only place where it matters. Unbounded for loop, 188. Like this, boom. Okay. Expected 4 arguments, found 3. So in main.zig 239, we used to call this chamber directly. We'll just comment this out because this is going to get replaced very soon anyways. We shouldn't be importing this module at all. So let's kind of like just delete kind of everything associated with this. Comment this out, comment this out, comment this out, comment this out. Oops. Is that all of them? There's a couple more. Here, I think we can just replace this with something like this. No, wait, this can all be commented out too. What am I doing? What am I talking about? This is not where I thought it was. We can comment this out as well. 81. We missed one more. This guy goes away. Or I guess what we'll do to avoid breaking more code is this one is the one that we want to say. We'll just initialize with some empty shit. I've read an ampersand here, maybe? All right. All right. Chillin'. So what were we doing? We were trying to shove balls into this chamber thing. So now we should be able to write some sort of like function step on our wasm chamber abstraction. And he is going to do something. We can look at this API for step. And so we're just basically gonna copy these parameters. So our state is going to be an I32, because I32s are pointers when we pull them out of wasm land. The balls are going to be this, and the delta is going to be I32. Okay, and then we should just be able to kind of convert this pointer and call it a day. Yeah, so the internals of this function are going to look very similar to the internals of every other function, except our input is going to be an array of 1, 2, 3, 4 values. So it's like this in this language. 4 goes here. Our first thing is going to be the state. The second thing is going to be balls. Oh, fuck. We need to copy the balls into wasm memory. So we have, before we get to this, actually, let's see. How do I do this? Let's comment this out. Get the fuck out of here. We need to basically ask the allocator of our plugin for an amount of memory that we can use. Oopsies, I didn't mean to. Maybe type def wasm pointers equal to I32. That's not a bad idea. That's not a bad idea, but I'm not going to do it right now because I'm feeling a little lazy. But I believe that you are correct and I should do that. But I'm just not. Okay, so here we say that we have size. And I guess technically we should put an alignment here too, huh? Because, like, if we alloc something and then copy it in and its alignment is wrong, it won't work. So we should just do that. We should pass in an alignment here. Which means that this guy should take in a size and an alignment. Which means that here we have to use, like, what is it? Alloc with options. So we're still going to do a U8 slice. And then we are still going to do size, but then we're also going to do alignment. And then here we'll just do like, its alignment is, I think, a U29. Optional alignment U29. Why? Why is it a U29? Is it because it's like, it's how do I say this? It's like masking out some bits or something? Like, const A is alignment or align of T. Okay, so we know that since align of returned us 4 earlier, that like the correct value is to write 4 here, but I just don't understand it. But that's okay. That's okay. Oh, we should do like const alignment U29 is equal to the U29 stood math cast U29 alignment, or else panic. Invalid alignment. I think U29 is an LLVM thing. I'm pretty sure it changed recently to U32. Interesting. Because I can imagine that, like, you would want to reserve some bits for something if you know that your alignment can never be less than some amount or greater than some amount. Like, I get it, but it's just I don't understand why it's like exposed that way. There's something that like doesn't make sense to me there. But good to know. Okay, so alloc with options, he takes an optional alignment and optional sentinel, which we don't care a fuck about the sentinel. So then we can say const ret slice is equal to this instead. Okay, except here we need to use alignment U29. And we're chilling. Okay, so now here we need to, when we initialize our plugin, we need to look for the allocator function, which is just alloc. And then we call alloc function here. We need to store this thing, so we'll say alloc function here. He doesn't like that there's some sort of shadowing going on. Who is shadowing? I don't understand. I don't see any. Oh, fuck. We'll call this alloc wasm. That way, there's no name collision. Cool. And then here, we just need to call that function, so. I want my allocation to be aligned by a gigabyte is stretching it really kind of, yeah. It's, yeah, the idea that, like, you're telling it, like, yeah, give me, like, a 1 byte thing, but align it to, like, a gig. You're like, what are we? We're abusing it. We're abusing our power in some way, shape, or form. Okay, so first thing is size. This is inputs plural now with 2 inputs. The first one is the size, and the second one is the alignment. And these have to be int cast. Stood math cast I32 size, or else something return error invalid size. I'm gonna do the same thing here. Stood math cast I32 alignment, or else return error invalid alignment bucket. Then here we return inputs, and the length is inputs len. And he's going to return to us some outputs, which is going to be the pointer. So I guess we can just say that we have one return value, and then we just say result here, 1, and then at the end we can like pull the shit out of our result. So here maybe we say result dot kind is equal to c wasm kind wasm I32. Wasm time I32. If this is not true, we've got a fucking problem. Return error invalid response. Response. Like this. And we're chilling. Okay. So now, when we are writing our step function, we should be able to allocate, but we also have to deallocate, actually. So we're going to call this free wasm. And I guess here we'll pass in the pointer as a I32. This actually has to return a error I32. Hashtag free wasm. Yeah, I was thinking that when I saw it. I was like, it's somebody's gonna make the joke, and they'll be right to do it. Okay, so this is now input thing. Instead of doing this, we just say pointer. We pass in our inputs as an array of length 1, and we don't have results, so we can say here, nothing to respond with, please. Fuck off. Go away. Boom. Okay. So now, in this function here, our step function, we should be able to allocate some wasm memory. Our API here is like a little odd. A little bit odd. Because of the fact that the... How do I say this? To free memory, our allocators in Zig need both a pointer and a length. We can't just do like C style malloc, like void star malloc, free void star. We can't do that because we need to pass in like a more complex type, right? This ends up being like slice, right? But now we're in this weird scenario where this like slice type that we use that has like a pointer and a length can't be like exposed over the C API. And if we try to like make a struct that has a pointer and a length, wasm code automatically turns that into like an output parameter, and I like don't really understand the rules of how you're supposed to know when something's going to be automatically turned into an output parameter or return parameter. So what we do instead here is we return a pointer to our slice. So it's like double in direction, which kind of blows. Oh, but it means that we like can be confident that it's going to be an actual return of an I32, which is nice for us. And then to like extract the actual inner parts of it, we call this like slice pointer and slice length function. So we actually have to make wrappers for those as well. So we will call it chamber zig. We have slice pointer and slice len. I guess technically we only need slice pointer here. We probably don't need to care about the length here. And we're just gonna say we pass in ourselves as a wasm chamber. And we have some pointer, which is a I32. And we return back its pointer in wasm memory. This probably makes sense. So maybe we should. Sorry, I'm just thinking. I think this is fine. I think this is fine. So maybe when we call Alec wasm, this should actually return. Well, he needs to return the I32 so we can free him. Okay. Yeah, okay, so we'll take in our pointer as an I32 and we'll return back a pointer that we can use externally. That makes sense to me. And so we're going to call some function whose input is our pointer. But his output is not null. His output is something valid. So his thing is result, and we need to check the type of the result, and we are going to expect that the result's type is an I32 as well. So we can just copy this. Boom. Now we need to take that I32 and we need to figure out where in wasm memory it is. So we've done this somewhere. It's here, I think, in our log wasm function. No, this is load. Where's our log function? Log wasm here. We call this function wasm memory data. And then this gives us where like the wasm memory as like a whole chunk. And then we can just kind of grab the offset from that. So here we have offset is this. And our pointer is this, but we need to use self context and self dot memory. And then we can just return p plus offset. I think. That feels fine to me. Oh, fuck, this is the wrong spot. God damn it. I just fucking did this in the wrong function. God damn it. I hate it when I do that shit. Okay, it's down here. Slice pointer. There we go. Okay, so now we should be able to, in our step function, we should be able to allocate some memory for the balls, which we need to actually, ball is equal to physics ball here. We should be able to say our input is this for. I already forgot. Hold on. I think that our input is just self alec wasm. Here we go. We want balls len times size of balls ball, and we want our alignment to be a line of ball. Chillin'. Balls pointer. Then we want like balls array is equal to self slice pointer given balls pointer. We need to defer a self dot free wasm balls pointer so that it gets the memory back. And then we can copy our balls in here. So we can just say I think that we can just yeah, I think this is fine. So we can say that this is a pointer to ball. And then we can say balls 0 balls len. yes. We'll call this wasm balls. And we'll just memcopy this shit. Right? I think that's fine. Because we know that the memory layouts are the same, and we know that we got the red alignment here. So I think we're chilling. Now when we call our step function, we have some arguments to pass in. The state, so that's this. This is going to be several inputs. So 1, 2, 3, 4. Inputs 0 is the state. Oopsies, fuck. Input 1 is the balls pointer, which in this case is balls pointer. Inputs 2 is num balls. So here, this is just going to be balls len, and here, I think it's fine. So here we're going to do stud mem. I guess here we already know that balls len casts okay because we used it here. So we can do like int cast here just directly. It's fine. And then input 3 is a float, and it's the delta. All right. Yeah. And then there's no return. So this is just 4, and that might work, maybe? To contribute a chamber, will you just need to upload a wasm executable? That's the thought right now, yeah. So we're just going to, like, at some point, it's kind of in flux right now because I've only made one chamber and it doesn't really do everything I want it to do. But at some point, we'll have, like, made enough chambers locally that we'll have an understanding of, like, what APIs are necessary. And then once we have that, then we can just, like, publish the APIs that we expect, and then people can just upload wasm executables. Yeah, exactly. Okay. This probably won't build. No fucking way. Runtime known argument passed to comp time parameter. Oh, fuck me, man. Really? Can I not allocate with a runtime alignment? Oh, fuck me. That fucking sucks. Alec, aligned Alec? Fuck, really? Why? There's no reason for that, right? I mean, clearly there is, but I don't know what it would be. Like, I would just think that the, like, all of the math for the alignment could be done at runtime. I don't see any reason that it would have to be this. Ugh. That really sucks. That really sucks. And I just find it hard to believe that there's not a way around it. Resize, realloc advanced. Slice alignment. Is this comp time here? Comp time int. Okay. Make this U16 instead of comp time int. Might have to use raw alloc. Yeah, that doesn't feel bad. That doesn't feel bad at all. Let's try that. Good eye. Thank you. So here we can do raw alloc. What is ret adder? At return address? What the fuck is that? Whoa, 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 whoa. Okay, hold on. That is confusing. There's a couple things that I've never seen in there before. Elemental PQRS, return address. This function returns the address of the next machine code instruction that will be executed when the current function returns. The implications are target specific and not consistent across all platforms. Fuck me. That's scary. So what does it use this for? What does it use it for? Raw alloc. Okay. Okay, so can we look at like an implementation of this thing? Can we look at like can we look at heap? Can we look at like our general purpose allocator or something? And look at like what raw alloc does? No. Allocator. Oh fuck, so he doesn't have a raw alloc. Am I high? Oh, I see. So raw alloc calls the internal alloc. Okay, so his alloc here has this red adder thing, and what does he do with it? He passes it to this guy. What does he do with it? He passes it to the backing allocator alloc. Fuck! What is my... Okay, we'll look at the page allocator. We'll have to look at the page allocator. And let's look at this implementation of it. And he has return address. What does he do? What does it do? What is it for? What is it for? Okay. Raw alloc. Somebody maybe will tell me. Okay, this is just very strange. Very, very strange. I can't imagine what this is for. Does another implementation use this thing? Like wasm page allocator? He doesn't use it either. Thread safe allocator. He just calls back to child allocator again. Like somebody must. Oh, is it just for the fucking logging allocator? It fucking is, eh? No, he doesn't log it here. I just don't understand. I don't understand. I don't understand what this is for. Might be used by GPA for tracing. But we looked at the general purpose allocator, which uses pay. I don't think we saw it in here. Maybe we did. RA, was it? Alloc. Ret adder. He calls alloc inner. Yeah, let's check. Ah, good eye, good eye, good eye, good eye. I see. I see. So it doesn't really matter. Essentially. Okay. Okay. Sure. So we'll just use raw alloc. And he takes an allocator, a length, an alignment, what is the alignment here? Alignment is U8 here. Yep. So maybe we just take this in as a U8 directly. There we go. And here we're at 0. I guess, fine. Fine, we'll write the return address. So I see, so they're doing something like saying, where does this, what function called this is like maybe kind of what's happening here. Is like you start your stack trace 1 up or something like that. Not really sure. But that's okay. So this guy returns an optional pointer here, and so instead of catch here, we'll just write or else, I guess. Okay, so here we have chamber 209, we got a bug. I see. So here we have to write this pointer and length out manually, which is kind of confusing, but that's fine. Okay, and then we have wasm chamber. We have an error at 154. Really? Expected type this, found error. Oh, I see. So this has to return, and this has to be failable in some way, which means that this slice pointer thing has to write try. And then at 142, he's got another problem. So what is it? Return type blah 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 is not allowed with calling convention C. Oh, right. Okay, we don't need to be calling convention C. We don't need that. Okay. Uh. So can we do something like in our main function, like just test this in some way? Chamber mod alloc 10 with alignment 4. Is this right? Oopsies, alloc wasm with size alignment. So p is equal to this, and then can we do like std debug print slice len is a how do we want to do this? I guess fine. Fine. We will implement the slice len. We will, just so that we can double check that we got the right thing. So this is fine. His result is an I32, and it's just he's gonna return instead of this pointer, he's gonna return the length. Okay. So here we should be able to say chamber mod slice len of p. And this should tell us 4 if everything is working correctly. Fuck off. I wrote I32 wasm time I32. This would be all uppercase. Okay. Okay, try again. And now he's mad. Expected type I32 found an error thing. So here we need to try this as well. And we finally made it. We finally made it. Okay, so we've got an internal error somewhere at wasm chamber 117. So this is here. This is failing at alloc wasm because we're calling the wrong function, which would do it. We fucked this up all sorts of ways. We copied the same function over and over again, which is kind of funny. Kind of funny. So we just need to extract all of those things now. Free slice pointer slice len. This is free, I think. Yep. Slice pointer slice len. And then we have to do the same thing here. So this is free function slice pointer function slice len function. Okay. Hopefully we're chilling. Not quite, because we need to define them up here as well. I forgot. So like this, C wasm time func t. There we go. Chilling. There we go. There we go. There we go. Okay. Slice length 10, which I don't think is what I expect to see here. Oh, we do, because we wrote 10 here, alignment 4, so we're chilling. And if we write like can we write like the address as well? Slice pointer. We didn't build. So none of our changes show up if we don't fucking build them. That makes a lot of sense. He doesn't actually like that. What is it? Is like this is how you log a pointer in this language? Okay, cool. Cool. So now let's try calling the step function. The step function. So we should be able to call chamber mod step with our chamber state, as well as some balls. Um, so I guess we'll just make this like 3 balls. Okay. And let's like maybe give them a position, a radius, I don't know, and a velocity. This doesn't actually matter right now because I don't think we're going to be using this for anything. So let's do this. Let's start with 1 ball, and let's just log the ball and see if it looks right on the other side. So here we're going to do balls like this, and delta is delta, like, or is like 0.1, doesn't fucking matter again. We just need like a number to pass in. Yep, and then we can go into our chamber, and we can, when we call step, let's just make sure that everything is, you know, correct. So we'll say that the balls are any, and the delta is a number. And here it's that the balls from 0 to non-balls, and the delta, yeah, we're chilling. So now everything should come up the same. Fuck! Really? Pause does not support struct initialization syntax? Why? Oh, did I forget an outer thing here? Error is ignored at 329, right? So we try here. Expected type I32 found some fucking shit show at 203. So balls pointer has to probably be try as well. Expected this thing found that thing at 203. So here's the pointer cast maybe. And align cast as well. Which is fine, I don't mind. I don't mind. 147, he's mad because this thing doesn't error out, which means whoever calls free wasm has to write try now. Here we'll just stood log error failed to free balls pointer. It's fine. Okay. Internal error, super sick at 225. So this is when we call the wrong function again. I wonder how many times I can make that fucking mistake. This is what you get for fucking copy pasting. I should never copy paste, ever. Ever. But I will keep doing it forever and ever because you can't stop me, and I will just continue to make this mistake for the rest of my life. At least the oopsies, why did I call it state function? This is step function. Step function. Vim theme is Sonic but in Alacrity with term GUI colors off, which creates this like weird fucking effect that I've just never bothered fixing. Okay. What did I call the right thing here? This is called step function. Okay, zig build and run. Okay, so this is super fucking wrong. Right? The delta is correct, but this is not what we tried to pass in. So we've made a mistake somewhere. Okay. Okay, so here we passed in balls pointer, which came from a wasm alloc. We copy. Okay, let's try doing this. Can we memset this thing to 0? And maybe we do U8 here. Times size of ball. Right? Let's see if we can get something that's like kind of at least represents something that we expect. So mem setting that whole thing to 0 also didn't do what we expected. We see radius set to 0 here and velocity set to 0, but like the position is not what we expect at all. which is surprising to me. Surprising to me. So did we fuck this up in some way? Here we do, like, let's just kind of hand wavy. If we did balls pointer plus 1 here, does it line up the way we expect? No. Maybe actually. Balls pointer plus 8 maybe is more. It's hard to say. Hard to say. Okay, let's double check. We have to check everything here. We have to check everything. So here we take in a pointer to some balls. Can we print the balls pointer as well? Maybe this will help. Balls is a pointer. And then here we can check what the balls pointer is. The debug print balls pointer is this. Let's just kind of feel that out a little bit. So here we got 2 different numbers. Oh, fuck me. It's because we made a mistake here. Here we should be passing in wasm balls. Because balls pointer is a pointer to a pointer to data. And so here we extract the pointer to the data, which is what we actually want. Oopies. Oopies. Which means that this actually kind of has to return 932. Which means this is all kind of confusing. So this guy can't return the memory data. This just returns result of I32. This stuff comes over here. So this is wasm balls I32 like this. Boom, boom. And then here the offset is wasm balls. So here this should be called wasm balls offs maybe. And here we return p plus offs. This isn't returning. We just say const wasm balls is equal to this thing. From 0 to balls len. No, we'll just maybe do this. Yeah. Like this. Yeah, that might make sense. 209 this is wasm balls offset. So now we get the offset, we add it to the actual wasm data, we mem set that shit to 0. Instead of mem setting it, we should actually copy the balls now. So mem copy this thing as balls, ball, this thing to balls len. This has to be pointer cast, align cast. And I think this will be fine. Maybe? So here we got 0.1, 0.2, 0.01, 0.3, 0.4. That looks a lot like what we typed in here. 0.1, 0.2, 0.01, 0.3, 0.4. Let's fucking go, baby! Let's go! So I think we've successfully passed in 1 ball into the chamber. Yeah. That's sick. At the end of this thing, we actually have to copy the balls back. So here we can do something like after this function call, we just do mem copy balls, wasm balls. From 0 balls len. There we go. And then at the end of this, we should be able to see if we change the state of the ball inside the wasm module, we should be able to see that change applied here. So we should do, we can call this like balls after, and we take the balls here. And then all we have to do is in the chamber, we can do something like ball 0 dot pause x plus equals 1 or something. And here we see a 1.1 on X. Let's fucking go, baby. That's pretty sick. That's pretty sick. So I think that we're very close now to having everything we need to actually just use this directly. So we should be able to go into our main application. And here, instead of importing chamber, we say const wasm chamber is equal to import wasm chamber.zig. Here, we need to make sure that everything that needs to be public is public. So this shit, this shit, this, oops, this. I think all of this stuff probably has to be public. Oh, we're missing the save function too, actually. But we'll come back for that. We'll come back for that, I think. Okay, so now in main, we should be able to do something like we have our wasm chamber, and we now need to load that wasm chamber somewhere, probably in main, before we construct this thing. This is going to end up holding in chamber is a wasm chamber, I guess. Chamber mod. And then chamber state is going to be an I32. Cool. And so here we're going to say const chamber mod is equal to wasm chamber init with some allocator from zig out bin chamber wasm. This will get fixed later, but for now we'll just use the thing directly here. We will say const chamber state is equal to chamber mod out. This has to be try probably. Chamber mod init chamber. Okay. Which means that here we can pass in the chamber mod and the chamber state. Okay. And then wherever we were calling step before, we should be able to call self chamber mod step with the chamber state balls and the step length. No, it was close though. We can dream. So wasm chamber zig. So we're missing some compile flags now for our main executable. So we can go into build zig and basically just copy everything that we did for wasm time test here and just kind of slap it over here. Yep. Chillin'. Link mode is redeclared. Fine, because I copy pasted something that I shouldn't have. Okay. Fuck. 455 in main. He doesn't like that this is const, so we'll make a bar. Fine, if you're going to be like that. He doesn't like that the error is ignored in 243. So here we'll just catch and say like stood log error chamber step failed. I don't know. It doesn't fucking matter right now. Does not matter for now. I'm running the wrong function, so that would do it, or the wrong executable. Okay, it's fucking spam printing, which is annoying. So can we go back to chamber zig and look for our step function that we... First of all, he shouldn't be changing the X position anymore. He shouldn't be printing anymore. But I think that's the only changes we made. And instead of checking, we will just blindly run it and see. Fuck. Balls. Pointer. Who is fucking logging that? This is fucking annoying. Okay, so he should be running. Interesting. Unreachable executed. Probably there's just a bug here with our, we nulled out the chamber state. So he's probably just getting fucking mad about that. So this will be like load chamber. We'll just kind of get rid of this shit. So this stuff was responsible for like rendering the chamber state, i.e. the platforms in our initial example. I think we can just comment that out and then everything else should be fine. No, he doesn't like this still. R is not defined at 63. I just didn't get it all. Right, so this stuff can go away too. But I think that's it. Okay, I forgot to clear the context. 0, 0, canvas, width, canvas, height. Let's try that. Okay, so, how do I explain this? There are platforms that are moving back and forth here, and we can visibly see the balls hitting those platforms. Right? Like here, you can see it rolling along a platform there. That's a really fucking good sign. Like extremely good. Right? Because what that means is that the physics that is happening in the wasm chamber is actually doing something. We're just not seeing it because we haven't hooked up like the save and load calls, which are required for us to like basically ship state over from one end to the other. Oh, that's super fucking good. That's super good. So I think the last thing to do is just to set up that save and load shit. So here we have a function save somewhere. Why the flicker? I'm just fucking up something here. This clear rect is doing something fucking. I'm just doing something dumb. I don't know what, but it's almost certainly related to this. Here, instead of doing clear rect, let's fill rect. Let's see if that changes anything. Balls are flickering now. Yeah, I'm not actually really sure. That is surprising to me. Here we begin a path and we stroke. Oh, here we stroke a rect already around the thing. Oh, but that should be fine. And then we iterate over the balls and then we fill each of those balls. Maybe we have to do like a begin path. No, I'm not sure. I'm not sure. Yeah, because it doesn't seem like it should be. Oh, there. I don't know what the fuck I just changed, but I changed something. And now it's behaving the way I expect. Yeah, cool, cool. Yeah, that's super sick. Okay, let's get the platforms back. Let's get them back, baby. So chamber zig, this save function. We were kind of hard coding this like 20 byte array coming out of it before. This isn't gonna make sense anymore. So I wonder what does make sense. Probably we ask. I guess this thing will just return a pointer. Sorry, it'll just return a like this. And then we can just call alloc save size with like 1 byte alignment. Maybe we'll, like, yeah, 1 byte alignment's fine. And ret is, what does this return? An optional pointer to something. So here we'll just, or else return null. Yup. Yup. Then here we're just going to have to do this, put some dereferences here on ret access. This would be an export function. Wasn't begin end path or something required to clear previously drawn shapes before? Yeah, it could be something like that. I'm not really sure. So now maybe our wasm chamber, when we save, he is going to do something like have some sort of save function. And he's going to return something that has to be freed. So maybe what we'll do is we'll like call this save function, free the wasm memory, and then return some of like our memory that we've copied it out of. I think that probably makes sense. So we'll say this guy returns a const u8 like this. We will extract the save function here. So we need to write down that we have a save function here. Then we have save function equals save function. Copy paste there is fine. And then somewhere we are going to have to do something. So we are going to, we don't need to allocate anything, but we do have to free something. So here we're probably going to call like, okay. We have some inputs. The inputs are just the state. So we write this. Inputs is no longer a vector. It is just a single element. Because there's only one of them. We delete all this shit. This calls the save function with input length 1. But he is going to have an output. And his output is a pointer. So var output, or result, I guess, is a wasm time val t. The kind is 932. No, we don't have to do that here. We just want to verify the type at the end. So here we'll say if result kind is not equal to c wasm time I32, return error invalid result. Here at the end, we are going to say if this happened correctly, then we can free this thing, which is result of I32. Okay. Then we're going to have to do something like copy this into something that we actually allocated, which means that this is going to have to take in an allocator. Oh, we actually have an allocator. But we want to use one that we pass in. Pretty sure. Pretty sure. So here we can just say, where does this thing come from? So we have C memory. Where did we do this before? This. Essentially this. So we have the pointer, which is the self to memory. The offset is the int cast of result of I32. Save data. I guess we have to pull out the len as well, which is going to be slice pointer. Oh, this actually has to be slice pointer here, result of I32. Yep. And then this is going to be int cast self slice len. Nice. Result of I32. Chilling. And then we just pull out the pointer plus the offset. This is saved at a U8. Uh-huh. Yeah, this feels good so far. And then we just have to copy this shit out. So we say like alloc dupe U8. Hello? Why is it broken? Dupe takes in a type and a slice. So here we just have to save data 0 to len. Yeah. Seems reasonable. Yeah. Okay. So in main now, we should be able to call save. I don't know where we were calling before. Here. So where is this? This is in history parsing. I don't really give a fuck about this right now. I do care about us trying to send it off. So here we'll say const chamber save is equal to simulation chamber mod save simulation dot chamber state. This has to be tried. And if this succeeds, we have to alloc free chamber save, which means that here we have to pass in our allocator to allocate it. And then here we can just write chamber save, which is chamber save. Yeah. And then maybe it works. That could do it, to be honest. Here we have an error that we have to check at 227. So this has to be try for both of these guys. Everything that we do in wasm could fail. And let's see if it works. Nope. Of course it doesn't. So this is at... Oh, because I freed the pointer here like a fucking dumbass. I freed it here, but it needs to be freed here. Because we're like, we lock the mutex, we pull some stuff out, and then we use this thing down here. And if that chamber save is deallocated, then it won't work. So we just have to maybe do something like... I think you can do this. And then alloc free will do nothing if it's an empty slice. But then we can reassign it here. And it will then get freed correctly, I think. Do I have to do this, maybe? Okay, refresh. We're seeing nothing here, which is not good, but we also commented it out. So that would do it. So let's uncomment all this shit and see if we get our platforms drawn correctly. Oh, it's beautiful, man. That's so fucking sick. That's actually so fucking sick. That is so cool. That is so fucking cool. So this is now 100% WASM environment. The balls are handled by our like native Zig, but they are being copied into the WASM chamber. The platforms are moving. They're being bumping around. We like ask the WASM plugin for the current platform state, and then we send that off to the website, the web client, whatever you want to call it. He loads the same WASM module on the client that is running on the server and like injects the state back into it, and then asks the WASM module to draw pixels onto a buffer, which draws these platforms, and then they're in the right spot. That's so fucking sick. That's actually so cool. Oh, that's so fucking cool. Okay. I'm trying to think what makes sense here. We're at an hour and a half, and I'm trying to think what makes sense to do for half an hour. Because I wanted to make a C chamber, but I'm not really convinced that that's going to go fast enough. But maybe the idea of supporting multiple chambers would go fast enough if we just ran a simulation for 2 chambers next to each other and like kind of figured out the WASM loading interface for more than one chamber. I think that could be done in half an hour, probably. It's possible. So let's do that. Let's do that. This is 0128.0. Okay. So git diff, why am I git diffing? Like anything in here, I'm not just gonna like blindly accept. Am I missing anything? Git commit -m, checky pointy. Okay. Okay. So let's try to like just rip through multiple chambers. So I think right now that everything is like kind of like contained in its own module, it should be pretty easy for us to do something like, we have a WASM chamber. Let's just make 2 of them, right? There's something odd here where we actually have some stuff that's like entire WebAssembly runtime specific, and some that's like this specific module specific, if that makes sense. So probably what we should do is maybe we want to do something like, I have a WASM loader. Well, yeah. Yeah, let's do that. Okay, so let's go back here. We'll go back. We're going to keep one chamber for now. We're going to make a WASM loader, which holds this stuff, I think. Then here we're going to have some sort of init thing which creates those things. So we'll just kind of yoink this part of init. And here we can just return engine is equal to engine, store is equal to store, context is equal to context. Okay. We don't need allocator and path here. And then down here, we'll have a pub function dinit. And he's just going to dinit that half of the stuff. So we have store and engine. The chamber, the context doesn't need to be denited for some reason, but that's fine by me. And then we'll just have some function load. And he's going to do this part. Basically, he's going to return a wasm chamber. And I think we just kind of copy paste this whole thing, delete this part, and just kind of start fixing out anywhere where it gets added. So self dot here, there's no self, so here we need a self wasm loader. Yup. The engine, store, and context aren't staved here, but this stuff is. Cool. So now we just gotta get rid of this shit. Does he actually need the context? He does. He can copy the context out. So here we'll say context equals self context, I guess. But that doesn't need to be deinitialized in any way, shape, or form. This init function kind of dies now. And dinit on this thing, all he has to do is delete memory. Yeah, okay. And now this is only the stuff related to this specific wasm chamber, which I think is fine. And all we have to do now is in main, instead of initializing our wasm chamber directly, we say wasm loader is a wasm loader initialized with nothing. And then here we say our chamber mod is a wasm loader load, which doesn't seem to exist for some fucking reason. I actually don't know why. It feels like it should be. It's like build. No engine named engine in wasm chamber. So wasm chamber 28. Oh, I probably just put the wrong return type here. This should be wasm loader. That would do it. Okay, we're getting closer. 464 in main. What is he mad about? Expected error unit type found this thing. Oh, because I wrote try here? Does this not fail? This must fail in some way. So that should fix it. No function named init at 368. In 368 in wasm chamber. Oh, right, because we have our main function here, which we don't need anymore. Sure. Okay. Root struct file wasm chamber has no function named main. Okay, so in build.zig, we shouldn't try to build this wasm time test thing anymore because we've got it integrated. And maybe we're chilling. Okay. So now, let's quickly run that, I guess, just to make sure that nothing is like super fucked. Everything is chilling. And let's just make two of them. Let's just make two of them. Yeah. So we'll say chamber mod is equal to 2 wasm chambers. And then we'll just do for 0 to 2, we have some value I, and we just say, we'll fix dinit later. And here we'll just say, for each of these things, we have chamber mod I and chamber state I, which means that we have var chamber state is 2 I32s. Yep, chillin'. Then in our simulation, we have to use both of these things. So I guess we are going to have half the balls go to each chamber for now. I think that makes sense. So we're going to apply everything to each of the balls, but then just half the balls are going to go to each of these. So I think this is the only place where it matters. Self chamber mod for 0 to chamber mod len, we're going to call self chamber mod I with self balls, but from I times, let's see, num balls over I. Const, and this is I times this? No. So this is over self chamber mod len. There we go. So this is going to be like 10 balls over 2 chambers times I, which means that we're going to get 0 and 5, and is equal to I plus num balls over self chamber len. Which is, this is going to be 0 plus 5. This is going to be 5 both times. This is going to be 0 to 5 and 5 to 10. Cool. Then we just only pass in balls from start to end. Yeah. And so now the physics should only apply to each half the balls. And then we just have to be careful that when we render these things, we're going to want 2 canvases. Okay. That makes sense. And in our JavaScript, we're going to want to look at both of these. So we're going to have chamber and chamber 2. So that this is fine. In our index.html, we have canvas 1 and canvas 2. So here we're going to render what we're doing right now at canvas 1, except we're going to only render half the balls. So we'll just say over 2 for now, because we're going to hard code it. That's fine. We render these things into canvas 1. We have to adjust our response data, I guess, to kind of split the chambers. Oh, maybe we'll do it that way. That kind of feels like it makes more sense. Maybe we go into our main.zig, and where we are returning our data over to the client, somebody somewhere will basically just say that we have a double nested thing here. Yeah. So for each chamber, we will return this thing. So how are we going to do this? Response JSON is equal to 2 structs of this thing. And here, we're going to have to do one set like this, and another set that's like very similar. So this is balls, 0 to num balls over 2, which I think is accessible here. Yep. And this is num balls over 2 num balls. And we just need to pull out 2 chamber saves here. So this is going to be chamber save 1. And chamber save 2. I know this isn't really like the elegant way of doing this, but I'm just trying to get something, you know? This these have to be indexed here. Okay. How fucked is this? Init chamber doesn't exist at 485. Right, so this is chamber mod I init chamber. How fucked is it? Simulation chamber state at 87. So this is also 0 and 1. Okay, we have 10 balls found, pointer to 5 physics balls. Oh, I see. So this has to turn into maybe a just normal slice. Found I32, expected 2 I32, so 262. Oh, here. This also needs an I on it. Okay. this is going to be super broken. But if we refresh here, we can at least see. Oh, he doesn't do jack shit. Okay. Why? What the fuck? Canvas is null? Oh, sure. We'll fix that. Canvas is null. So we'll say canvas 1 here. We'll have to load the chamber twice in JavaScript as well, probably. But for now, I just want to see that our like network response gets hit. Really? Canvas is still null? Oh no, we're fine. No. Canvas is null. Here at render. Index.js 45. Oh, oops. That would do it. That would do it. Okay. So our simulation state is a response with 2 balls with our 2 chambers with what seem to be the same chamber state, which is kind of funny because there isn't any randomization on initialization, which is a problem. We should fix that. But for now, we have 2 chambers that are exactly the same, but probably the balls in them are different. That's fine. That's fine. We'll have to randomize the positions of the platforms in the chambers eventually. But let's start by getting something with what we have now. Maybe we'll call this chambers, and chambers is this. Chambers pixel data is this, an array now instead of null. Now everything that uses the chamber actually has to take it in because we don't know which chamber we're going to be working on, which is fine. We'll just have to start shoving this in everywhere. And then we can actually maybe get clever here, and we can render chamber, canvas, and simulation state here. And then we can just call render twice, maybe. Maybe not. Maybe not. Here, we'll probably do something different, but we'll see. So here, we're going to do something like chambers push obj and chambers pixel data push chamber pixel data. Like this. Yes. Yeah. Yeah. I guess we say const chamber is equal to obj like this, which makes this work. And then we just do this again, but we say that this gets assigned to canvas 2, but everything else just kind of works out. Maybe it makes sense to kind of like chain them together this way. Yeah, I'm okay with that. And then at the end of this one, we call render. Cool. I think that makes sense. We will see. Okay. Now on render, we have to basically split by chamber. So for int I is equal to 0, I is less than simulation state length, plus I, we have now 2 sets of simulations to render. So all of this stuff now kind of goes in that for loop. And we indent it in a little bit. And now everything just needs like chambers I. Chamber. Where does chamber state come from? Chamber state comes from here. So this actually also goes here. Load chamber needs to take in a chamber, so chambers I now. Simulation state is simulation state I. Boom. Which canvas we're using actually has to adjust here. So here we're going to say canvas is equal to canvas plus I, and then that will string serialize. I guess we need I plus 1. So it's off by 1. This needs to be var I, let I probably in this language. And we just keep going. We just keep going. So we have our canvas. Chambers I gets chamber state, chambers pixel data. I get chamber pixels probably needs a chamber to be passed in now. So chambers I, chambers pixel data I. Chambers I. Is that everything? Maybe. This needs to be J now probably because we have an outer I, which means that here this needs to be J here. Do you use Git? Because I never see you commit or anything. I do. Thanks, Two Step, for the bug check there. I try to do my Git commits off screen because I think they're like kind of boring. Especially because like the way that I work on stream is we kind of try to make like rapid progress, right? And it just kind of means that when I work by myself, I try to chunk the work a little bit more cleanly. Where I say like, okay, we in order to do like this task, we might need to refactor this stuff first. And then I'll like go back and I'll do the refactor and I'll make sure that all of the stuff related to the refactor is in like one commit before I start the next one. But like the way we work here is just like we get to see more progress if I just like don't think about that kind of thing. And so it means that like my commits can't be reasonable. And so I have to do all of this like rebasing at the end to make sure that I squash all of the right stuff into the right spot. So what you'll actually notice is if you look at the end of stream, I will often push a work in progress branch to my GitHub. Well, I push it to my local repo, which happens to mirror to GitHub, but you would see the changes up there. And then like over time, those things get kind of like pushed more towards like reasonable commits. But if we like look at what's in here, right, we should have like reasonable commits split by concept with like good commit messages. We at least aim for it a little bit, right? Let's see, like, something like this. We do end up with like major commit messages with like split by concept. So we do use it. It's just I try to avoid getting lost in Git shit on stream. This needs to be J. I think that's it. We'll see. I'm sure this is fucked in some way, shape, or form, but we will just kind of work through it. Simulation state balls is undefined. So probably here somewhere we have simulation state needs to be, this has to have an I on it. What the fuck is going on? Computer? Hello? Okay, I'm still moving, but the, oh, fuck. I don't know, something just froze. Okay. So that's promising. We do see two sets of balls in two chambers that are behaving differently. The platforms are kind of annoyingly following the exact same path, but I think that we could maybe just seed our chambers with a different number, and maybe that helps us in some way. So let's go to our chamber zig, and we'll just kind of say that on init we take in a usize. And here, we'll basically randomize the x positions of each of our platforms. We can do something like const RNG is our var RNG equals to stood random default prng initialize the seed. And here we just say RNG, and then we have, I think this has to also say var random is equal to RNG random, so we get the random interface. And then just for each of our elements, we can do what, like for 0 ret dot platform locks len. We'll just say platform locks I is x position is equal to RNG random, float. Yeah. And so now we need to go back into our wasm chamber interface, and on our init chamber, We need to take in a seed now. Ooh, we gotta be careful here. We have to be careful here. Chamber.zig. So our PRNG, what does he want to be initialized with? Is it with a U size or U64? U64. Okay, so I think that we can just... I don't know what happens if we do U64 here. This is actually an interesting test because I don't know like how low level the WebAssembly interface is. It might split this into two registers, two parameters. Oh, well, I guess we know that we can't... We have to pass in wasm time val t's, which cannot be... Oh, that can be I64s. Okay. So let's see what happens if we do this. So can we do, like... We have some input here that we now pass in when we in the chamber. But this is I64 is int cast seed. This should say I64 now. And here we just pass in input and 1. And I wonder how fucked that is. I wonder. Can we just use here PRNG random int U64? Like, is that allowed? Expected type U32 found U64. Am I high? Oh, yeah. I am a little bit. Just a little bit. Okay. Integer cast truncated bytes. Bits. Oh, do I need to bit cast it, not int cast it? That makes more sense. Yeah. So here we get to bit cast, probably. Okay. So our platforms are in different locations, which is good. I just don't know how to prove to myself that they are in the correct different locations. I also want to look at wasm to watt of this chamber wasm, and can we look at what is our init function? Here we have init function is func init, so we can search for init here. And, oh, okay. Okay, so he does take in a single parameter I64. So that's like something that exists in this language, which is good. That's really funny. I know that it's like, it shouldn't be that funny. This is just like the local variables that are used in this function. But that's really fucking stupid. That's just really funny to me. Probably it looks a lot cleaner if we do optimize release small. I think probably what we're seeing there is we're seeing how do I say this? We're seeing Zig just do whatever is like the simplest thing to translate from Zig code to wasm code. And that results in a lot of stuff on the stack. But it'll be interesting to see if we do this, if it changes. Also, what's kind of weird is that like there's like this concept of like the stack in our WebAssembly module where like things that need pointer addresses end up being allocated from WebAssembly memory. But like variables that are stack variables don't show up in that stack unless they get an address, which is just very strange, right? Because like they have like, oh my god, holy shit, my computer is like losing its mind. Wow, that pointer, that dot is dragging so fucking far. I don't know if you guys can see where my cursor is in like the recording, but that was fucked. But they have like memory, right? And like, so if you have like ball, right? And you have like ball is equal to ball. And then you try to like pass that ball to a function. So you say like, you know, you have like function that takes in, oh Jesus Christ, like a pointer to a ball. Zig will have to go like, okay, so I'm going to call this function, which means that this ball needs to live in memory somewhere that's accessible, right? So that makes sense. But it only does that for things that need to be in memory. Otherwise, that like local syntax, right? I32, I64, I32, right? All of these locals don't have memory addresses, which is just really strange. It's just really strange, right? Where like normally you would expect that kind of like all of your variables end up on the stack, right? Like the most naive implementation of something with like no optimizations would just to be to use like your stack pointer and just, oh, I have an int, put it on the stack. So it's kind of weird that you have like two stacks in WebAssembly. It's just kind of weird. This probably looks a lot more sane. So we need to look for init is func1. And yeah, so now, oopsies, now our func1, which is this guy, only has 1, 2, 3, 4, 5, 6 local variables, which makes way more sense. So kind of interesting, kind of interesting. Okay. So I wanted to prove to myself that these things are just loading with different seeds, but we can just prove that pretty easily by going into chamber zig and just calling print with seed. So maybe we'll, or print platform I or this going to there. And we will just say pause here. Or ret platform locks I and write this afterwards. That makes sense. Fuck. Too few arguments. Oh. Fine. If you're gonna be like that, I fucking get it. Yeah, so here we have 0.1, 0.9, 0.3, 0.4, and we have 0.8, 0.8, 0.0, 0.5. So, or 0.83 again. So in the second chamber, we should see that there are cases where all three of these guys line up. Oh, but they probably started going in different directions, but we do see like these two platforms lined up. Oh yeah, that's pretty sick. That's actually like super sick. I'm pretty happy with that. Probably we were going to have to. What the fuck is happening there? That was weird. But yeah, probably at some point we're going to have to basically like dynamically create these chambers, and we're also going to have to like feed stuff between them. But the idea of us having this, we've effectively instantiated two WebAssembly modules. I know it's like the same WebAssembly module twice, but like from the perspective of the system, we really have just instantiated two WebAssembly modules, which is pretty sick. We have two chambers running like what happens to be the same code, but could be different code. And that's, yeah, I'm pretty stoked on that. That means we're not, what the fuck is going on there? That's so weird. Whatever the fuck that was, it's really weird that those two balls get like hung in that state in the same location on both chambers. I wonder if I've got one ball being fed to both chambers by mistake or something stupid like that. Anyways, I'm quite happy with that. Thanks for watching, guys. If you liked what you saw, we stream most days at around 2 o'clock Pacific time. Right now, we're working on this like Rube Goldberg machine thing, but there's a lot of other stuff if you want to go check it out. So there's a YouTube link in the Twitch description where we have playlists of all of our projects, as well as a GitHub link in the Twitch description where code for all of our projects goes up if you are inclined to check that kind of shit out. If you're watching on YouTube, there should be a Twitch link in the YouTube description. Swing by, say hi if you're online between 2 and 4. I mean, I can't tell you what to do. I shouldn't say swing by and say hi. I should say, if you want to, you could swing by and say hi. That way, I'm not an asshole telling you what to do. Like, subscribe, Twitch Prime, you know, all that shit, because I have to remind you guys that you do it, and then I can like maybe keep streaming for longer. You know, it's like useful in some way, shape, or form. What else? I guess that's it. Goodbye, YouTube. Twitch, let's figure